All right, so we're going to look at section 6.4, which is on finding all, or finding all the factors of a higher degree polynomial. So converting from standard form, or we call that general form, into factored form, or also intercept form. So our learning goal, our ultimate goal, is to determine all the zeros of a polynomial, both real and imaginary. So we use all of our mathematical knowledge and resources to find all the zeros. So the numbers of zeros are evident by the x-intercepts. So some zeros you can see on the graph. Those are real. And some zeros that we need to find are imaginary. So we have some options. You can factor by grouping and then solve. That only works some of the times. You can find the zeros right as a factor and then divide using the rectangle method or synthetic division and then solving the remaining polynomials. So what we're actually going to do is focus mainly on synthetic division. So in order to do that, what we're going to do first is look at this polynomial and find the zeros with a calculator. So in putting that in, we have x to the third power minus 2x and then squared, and then minus 3x and then plus 6. Verify that I have the correct polynomial and then graph. Now, it looks like we only have 2 zeros, so I'm going to zoom in though over here on our 0 and take a closer look. So I actually see we have more than 1 0. So I'm going to calculate those zeros by pressing second trace, finding a 0. And then we see the first 0 is x equals 2. And then we have x is about 1.73. And then we're going to find this one over here. And we have negative 1.73. So x here is approximately negative 1.73. Now I'm going to focus on using the real root of 2 because these roots, the 1.73 and the negative 1.73, are approximations. So I'm going to use synthetic division. If the root is written like this, that is what I'm going to divide in synthetic division. Now I'm just going to keep track of my terms. So I'm going to write, here's where I write the coefficient for my x cubed term, and then my x squared, and my x. And I'm going to write c for my constant. So in looking at that, I have 1x squared. So I write 1, negative 2 for x squared, or I said 1 for x cubed, so 1, negative 2 for x squared, so negative 2, negative 3 for x, and then 6. And then the synthetic division process, you bring the 1 down, so that's 1. Then I go 2 times 1 is 2. Adding negative 2 and 2, I get 0. 2 times 0 is 0. Negative 3 plus 0 is is -3. 2 times -3 is -6. And then that makes 0. So if I have to recode this, this is my constant. This is my x term. This is my x squared term. So in here, I have x squared minus 3. Now, I need to see if I can factor that further. So essentially, what I'm doing here is taking x squared minus 3 and setting it equal to 0. And I notice that I can solve that directly. So I'm going to add 3 to both sides. And then I get x squared equals 3. And then I take the square root of both sides, and I get x equals plus or minus the square root of 3. And then I'm just going to check, is that approximately 1.73? And as I look, the square root of 3, that is. So all the zeros, we have x minus 2, or x equals 2, x equals square root of 3, and x equals the negative square root of 3. In writing that polynomial in factored form, we just subtract over or add over the numbers. So x equals 2 would make x minus 2 in parentheses. X equals a negative square root of 3 would be x minus the square root of 3. And then x equals the negative square root of 3 would be x plus the square root of 3. So now we have to find all the zeros of this polynomial. So we're going to put this polynomial into our calculator. So I'm going to press y equals, clear out my old function, type in x to the third power. So again, use that arrow up key to put that in, plus 7x squared plus x and then plus 7. I'm going to go ahead and graph that. And it looks like I only have 1 0, so I'm going to calculate that. And I put my left bound and then my right bound, focus on the 0, and I get x equals -7. So now to divide those out, that's what I set up in synthetic division. So -7. And then I line up my terms. I have my x cubed, x squared term, my x, and then my constant. Writing the coefficients, we have 1x cubed, so 1, 7x squared, so 7, 1x, so 1, and then 7. Bringing down my 1, we go -7 times 1 is -7. Adding those, I get a 0. -7 times 0 is 0. 1 plus 0 is 1. -7 times 1 is -7. And then that makes a remainder of 0. Then, ladies and gentlemen, we write our terms. That is our constant. That is our x term. That is our x squared. So we would have x squared plus 1. Then in looking at that, I can solve for those zeros. So I have x squared plus 1 equals 0. And then in solving that, I subtract 1 from both sides. And we get x squared equals -1. Taking the square root, I would get x is equal to, the square root of -1 is I, so we have plus or minus I. So the zeros of the polynomial, the real zeros, we have x equals -7. And then the imaginary zeros, we have x equals positive I and x equals negative I. So in writing the polynomial in factored form, we're just going to do that with the real zeros. So if I change x equals -7 into a factor, we would write y equals x plus 7. And then I noticed that my x squared plus 1 could not be factored into real roots. So I'm going to put that in factored form as well as x squared plus 1. And then notice we could also check that to make sure we are correct. So I could put that into my calculator and type in x plus 7 and then times x squared and then plus 1. And then graph that. And you see that that goes right over my other equations. So let's have just a little bit more practice. So I'm going to put this function into my calculator. So I'm going to press y equals, clear out what I have in there. Type in x to the 4th, so x caret key 4. And then plus 3x and caret key 3. And then plus 12x and then minus 16. Graph that. And it looks like I have 2 roots. So I'm going to calculate those. And we have x equals -4 is 1. And then our other root, x equals 1. So I'm going to start with synthetic division. So when the root is -4, we just put that in the corner. Then my coefficients are going to go from x to the 4th, descending, so x to the 3rd, x squared, x, and then my constant. So I notice I have 1x to the 4th, 3x cubed, no x squared, so I'm going to put 0. Most mistakes are there. And then 12x, and then -16. So the process of synthetic division, I bring the first coefficient down. So I bring the 1 down, and then I multiply in this line to get those. So -4 times 1 is -4. Then I add here, 3 plus -4 is -1. -4 times -1 is 4. Adding, I get 4. -4 times 4 is -16. Adding, I get -4. -4 times -4 is +16. Adding, I get 0. So in looking at that, that is my constant, my x squared, and my x cubed term. So in looking at that, I have x cubed minus x squared plus 4x and then minus 4. And then we actually know there's another real root. So we're going to take this x cubed minus x squared plus 4x minus 4 and divide it by 1. So I'm going to put my 1 here. And then coding that, I have 1, -1, 4, and -4. So I bring my 1 down. 1 times 1 is 1. And then adding, I'm going to get 0. 1 times 0 is 0. Adding, I get 4. 1 times 4 is 4. Adding, I get 0. So here's my constant, my x term, and my x squared term. And I notice that I get x squared plus 4. So in moving all of my roots or finding all of my roots or zeros, so my zeros, I have x equals -4, x equals 1. Those are my real roots. And now to get my imaginary roots, I notice that I can solve that directly. So I'm going to subtract 4 from each side. And you get x squared equals -4. Taking the square root, x would equal The square root of 4, we would lose the I, and then the square root of 4 is 2. So x is going to equal plus or minus 2i. So we have x equals 2i and x equals negative 2i. And then in looking at that, to write the polynomial in factored form, I would take my factors, x equals negative 4, add that over, and change that to x plus 4. And then take my x equals 1, subtract that over, so x minus 1. And then I notice that x squared plus 4 does not factor, so I'm going to write x squared plus 4, and that can't be factored into a real, to have real roots. So that would be my final answer.